how to do the vector addition using the polygon method. So let's do the vector polygon method. So in the vector polygon method, what you have to do, you have to use two types of what we call the two types of laws. One is the cosine law, one is the sine law. Let me give you some understanding behind this law. So vector polygon method. So in this, you should know what is head to tail rule of vectors addition. So what is head to tail rule of vector addition? Let me show you over here. I want to just grab something. Oh, the question is asked, Andrew, but how will our attendance be tracked for this week? Yeah, you will upload this the notebook on the D12 after about like maybe after about 30-40 minutes. I will open it the same way you have been doing it. Don't worry about it. So I will request you to upload the photo of what I'm teaching in the classroom today. Can you hear your professor? William says I'm having difficulty explaining. Let me know if you can hear or cannot hear. Can you guys hear your professor? Okay, that's good. Okay, thank you guys. So let me explain to you a little bit about the vector addition and how are you going to use the cosine law and the sine laws. So we will be using the cosine laws and the sine laws in this calculation. So let me show you this. Okay, now let's see. So in suppose if you have this vector and let me show you over here one more time. Suppose this is a body. Okay, this is a body and you are exerting a force in this direction and in this direction. How are you gonna use this? Suppose this is F1 at a certain angle maybe 0 degree, F2 at a certain angle maybe at 45 degrees. So okay, let's do the let's do this, the mass, and it starts moving. Okay, so let's apply the, suppose this is 10 newtons, suppose this is 10 newtons and this is about maybe 20 newtons. Okay, now let's see. So I want to show you that you can use these two laws. What are those two laws? To okay, first of all, head to tail rule. Okay, head head to tail rule of vector addition. So in that case, what I'm going to show you, I believe you might have done in the past, but look at this force 1. I'm going to draw the force 1 vector here at 0 degree and at an angle of 45 degree. This is about 45. I'm just guessing it 45 degree. And now the final vector, so if I show you with a different color, so the final vector would be the starting from the tail of the first vector and joining the head of the last vector. This is f2 vector, this is f1 vector, and this is the resultant vector. Give me 1 second. I see somebody is trying to join, so maybe. Okay, got it. Okay, please mute your mics. And now we want to make sure that you understand how to apply the how to use this. Suppose this is angle theta. This is 180 because this angle, can you type in the chat box what is this angle if it is 180 minus 35? 135. That's good. So you guys have understood this is 135 degree. 135. Okay. So the law of cosines, and there is another law of sines. You will be using these laws for finding the angles. Suppose this is A, this is B, this is C, and you can find out the. Okay, let's apply this law of cosine for finding the this side. This side is, so this is opposite to this. So look at this, and what I'm gonna show you, r square, you have to take the square of the sides and the adjacent sides, two adjacent sides, f1 square plus f2 square minus 2 times. Let me make sure I'm doing it correctly. uh, yes, this is correct according to. Just, do you understand this law, the law of cosines? Can you type in yes if you understood uh, the way I'm explaining you? And f1, Kobe says yes. Amul says yes. That's good. Muhammad. Okay, that's good, guys. I'm happy that you are learning. Okay, look at over here. So F1 is given as 10 newtons and 20 newtons. So I'm gonna take the square of. So can you do me a favor? Can you find out resultant from here? Open your calculators. Anybody who has calculated the R value? One student says 27.98. I need two, three more answers, then I will move forward. Please open your calculators and help your professor. William says 27.9. So that's good. So I just want to show you on my computer how I can see. Let's see. 100 plus 400 minus 2400 times cosine 135. That's good. I got 27.98. So that's good that you are getting this answer. I'm glad that. Please type in yes if you understood how did we calculate the resultant of the two vectors using the polygon method. Uzziah says yes. Emil says yes. I need two, three more yeses, then I will go to the next topic. Okay, that's good. I'm glad that you have understood. So let's go for the next law. The next law is the law of sines. If you can see here, this is the law of sines, and this is used to find out the angle of the resultant or angle of any other vector with respect to the horizontal. Okay, let me show you over here. I want to find out what is this angle, this theta. So the way I'm gonna show you, so this side r over sine opposite. Look at the opposite angle, 135. Okay, equals to, look at this side opposite angle. This is theta. Agree? We need theta, correct? So F2 equals to how much? F2 equals to, did I say 20 newtons? F2 equals to 20 newtons. F1 equals to 10 newtons. So can I write down 20 divided by sine theta? And R you just found was 27.98 newtons. This is in newtons. Make sure you understand the units too. So let me write down 27.98. So now guys, can you help your professor? So I wanna find out what is theta. Now it is your work. Can you open your notebook and show me the work? Or you don't have to show me right now, but just tell me the answer. Obi says 39.57. Any other student? Okay, let's do it together. So I need a few more students to answer, and then type in the answer in the chat box. So, and sine theta, Mosiah says 31. Okay, let's do it together. 20 divided by, okay, then I can bring this to the right hand side. Okay, let's do it together. I want to use arc sine 20 divided by 27.998 divided by sine 35. Oh my God, what is this? Maybe I haven't done like this. Yeah. So this is 30.36 in my notes. I'm glad that you guys are having the same answer. So now our angle for this resultant is with the horizontal, it is given now 30.360. So you see guys, this is known as the vector polygon method of finding the unknown. Now you see on this member, this is like a maybe a pole, and these are the cables, tension in the cables, and you have to find out the resultant force on this pole, and then you will find out the strength of the bolts to hold this pole. You might have seen these kind of situation in the light signals, and you have to use some. So what if you have more than two forces? It's not a big deal. So let me show you. If you have a case, let me show you over here. If you have a case in which there are more than two forces, so more than two forces, how will you do the law of cosines, law of sine? It's not difficult. Look, the way you will do, you will first of all draw this. I'm gonna focus on this triangle. So look at this is the resultant of these two forces, correct? Resultant one, and then this and this becomes this is one triangle. So now you will split up into like triangle 1, triangle 2. That way you can easily find out the unknown one by one. You see my point, guys? So you don't have to rush to jump find out all the values immediately. Do you understand the process? If you have more than two forces, how are you gonna split up the forces into triangles? Please type in yes if you understood this method. Sahil says yes. Amol, yes. Cole, yes. Kobe, yes. That's good. That's good. I'm glad you guys have understood. So when you have a question, you see the question which I'm gonna assign you is given in our. Let me show you. Last time I mentioned that we already solved this question in our lecture. Question number 7, I believe. Let me show you. I believe. Chapter number 3, I already assigned you, explained to you. So chapter number 4, the problems which I'm gonna ask you. uh, Let me see what problems you're assigned for the chapter number 4. Yeah, 7, 12, and 17. Problem number 7, 12, and 17. Chapter 4, 7, 12, and 17. Attendance will be taken. The question is asked how organized. You will submit your notebook picture upload on this class participation when I will open it. I haven't opened it yet, so please wait. Okay. So now let's go. We have already done question number 7 last time. I explained this question number 7 using the vector algebra. Today I'm explaining you can use the same question. You can use, let's use the same. I'm gonna use this, follow the same question with the different. So F1 is 1000, F2 is 800. So I'm gonna solve the same question now with a different method which is known as the vector polygon method. So let's change these values to the one which we changed last time, 1000 and 800. Okay, so let me change these two values. So now guys, let's solve this problem after we understood the vector polygon method. This is my 1000 pounds. Let me change the color to blue. So this is my 1000, and this is now 800 pounds. So I'm gonna show you the way I'm gonna solve this question at 1000 pound, and the second vector is like if I draw, look, if I draw it like this, Let me show you. Over here is like, okay, let me redraw this vector. This vector is at an angle of 50 degree. This is 50 degree. You can see this is 50 degree, 50 degree, and this is my 1000 pound, and this is my 800 pounds. I can get it. Okay, now this angle is 130 because the angle of a line is 180. You already have, this angle. So 180 minus 50 gives you. So this is my force one. Okay, let's see. This is my force one. This is my force two in pounds. This is pound weight or pound force. Okay, this is 1000 pound force. Now, guys, let's find out law of cosines. So I'm gonna find out the resultant is using the head to tail rule. Let's find out the resultant. So now I need your help. This is a triangle. It's just a very simple question, like r square, opposite side, or like two side, this one and this adjacent side. So 1000 square, 800 square, minus 2 times 1000 times 800 times cosine 130. And then you will use your calculator and let me know what answer do you get for this r. I want to see whether you get the same answer which we did in last time. I want to see whether you get the same answer, 1630 1633 pounds. Please type in the answer in the chat box. One student Amul says 1630. Good. Emily, you have verified this answer using the vector polygon method. I need two, three more. Sahil says yes. Is also verifying the answer. Two more students, then I will be happy. If two more students write down the answer, it means that you are engaged in the classroom. Alexander Monroe. That's good. Andrew Harrier. Good. Caleb. Good job, guys. I'm good now. Please, this is okay. Now let's find out what is the angle. What is this angle? Theta. So with the horizontal, I'm gonna show you this angle. So let's find out this angle. Law of sine. So I'm gonna show you this law of sine. So I'm gonna show you law of sine 800 opposite angle 800. Look at this opposite angle. This is sine theta equals to, let's use this r and look at opposite angle. This is 130, so r over 130. So now you will have sorry, this is sine 130. I have to write it down like this, sine 130. Now you will open your calculators and let's do the math. So I'm going to write down sine theta like this, sine inverse of sine theta. So 800 times sine 130 divided by r, which is this one. Okay, guys, 1633. So can you open your calculators and see if you get last time what we did? We got the angle. Did we get the angle last time? 22. I want to see whether you get 22 or no. Or let me do it on my end too. 800 times sine. William says that 22. Good job, William. Oh, look, this is the same thing. Sahil says 22. Good job, Sahil. Okay, Khalif says good job. I need two more students to write down the answer in the chat box. Then I'll be happy then. Is everyone trying? Leon says yes. 20. Andrew says good job, guys. I'm glad. It's good now. Leila says yes. I'm glad you. Oh, too many people just saying it. That's good. I'm glad that you guys are learning. Please type in yes if you have understood the vector polygon method and the vector algebra, both methods. Please type in yes. Otherwise, you can write down the answer question in the chat box, and I will try my best to help you. Lela says yes, Lucilia yes, Muhammad yes, call yes. Good job, guys. So I'm glad that you have understood the vector polygon method to find out the resultant plus vector algebra method. So now you can solve question number 7 easily. Our my next topic in my next question is question number 12. In order to solve that question number 12, I need to give you some theory. Williams, you are expected to memorize these formulas. You can write down, you don't have to memorize it. You can write down on your cheat sheet. Okay, the question number 12, but before we solve question number 12, I need to give you some theory. The theory behind this is the word is, have you heard about the torque or the moment or the torque? Have you heard about it? The what does movement say? Like if you are at home, you are, suppose this is the door, okay, this is the door knob, okay, this is the door knob, and this is hinged, this is my hinged, this is, and the door opens this way. It's the door, when you push this door inside, this is my line of action of force. Force is your hand, and then the angle is 90-degree. This is the moment arm. We call this a moment arm. So the moment of this force, moment means turning effect. You have to turn the door. The moment of this door is F times R. Have you understood this concept? Now the same thing. If you reduce one thing, the other thing, the torque, the moment will reduce. If you keep on decreasing the moment arm, keep on decreasing the moment arm, and until you hit this over here, the door will not rotate at all because R is 0. When you touch the axis or the hinges, R is 0. So when R decreases, it means you are decreasing the moment. Okay, let me show you another example. Okay, another example, suppose this is the axis of rotation. Okay, now this is the force. I'm applying the force on this body. This is the force. How are you going to find out the moment of this force? The way you will do this, you will draw a line passing through the force vector, and the line perpendicular to this force vector is 90 degrees. So you see this is 90-degree and this is R. Okay guys, this is the moment R cross F. You see my point, guys? So that's how you find the moment. And the next question is all about the moments of a force. I want to show you one more example. That way you will understand the question more clearly. So let me show you one more question here. So the way is, if suppose there is a gear. Okay guys, there is a gear. Suppose this is a gear and it is moving about its center, and this is these are the 2 points. The force is acting at these 2 points. Suppose this is tangent, this is the tangent to this point, and the tangent, the angle, the line between the tangent and the center, it is perpendicular to the tangent, as we have studied this. So this is my force. So how are you going to find out the turning effect of this force on the gear. So you will tell me, suppose the gear has 10 centimeter, or and this is maybe 100, 1000 newtons. So then the gear is rotating this way, so it will try to create a clockwise moment. So if I ask you, so then you will say, Professor, this is the turning effect of this force would be m times, sorry, this is f times r, f times r, and r is 10, so I'm going to write down 1000 times 0.1, 100 newton meters. This is the moment caused by this force, and this is also known as um, the perpendicular lever arm. So this is like a this is the moment arm or the lever arm. It is always perpendicular to the line of action to the of the force. Please type in yes if you understood the theory of the moment, then I will move forward to the next topic. Zaya says yes. Sahil says, I'm glad you guys have understood. So let me show you one more thing. Let me show you one more thing here. That how are you gonna solve another method? The moment of this force can be found using the components. How am I gonna solve this for components? So the way I'm gonna solve this for components, suppose you have a gear here, uh, and then this is the point. The point, and the force is acting like this. This is my applied force on this here. So the next method you're gonna I'm gonna show you, you have to resolve this force into vertical and horizontal components. This is fx, this is fy. This can also be translated here, so this you can write down, this is, it doesn't matter, you can either draw fx, it's like a rectangle or parallelogram, so this is fy. Let me ask you now, you don't worry about this resultant force. Can you tell me what is the turning effect of this force fy times r? What is r in this case? It is directly rightly above this center of rotation. Can you type in the chat box, if suppose this is 10 centimeter, what is r?
0.1.
Please type in r for fy. What is the moment arm? Jeremy says zero point 0.1 meters. I need 2 3 more students. What is the r value or the moment arm for the fy, which is the vertical component of the resultant force F? John says 0. I need 2 3 more students. Everyone, Can you try one more time, because this point one is not the correct answer. I need you. Let me show you the definition. The definition of R, look, the definition of R is the perpendicular distance from the line of action of the force to the axis of rotation. Now look at this diagram. This is the force. Perpendicular distance. What is the perpendicular distance of this force with respect to O, between the axis of rotation? Because I haven't seen the correct answer yet. Fy. I'm talking about Fy. Look, I'm looking for this R. What is the moment arm caused by Fy? Because I haven't seen the correct answer up until now. Or let me explain to you. If you are unable to understand, let me explain to you. Look, if this is a body, okay, if the force of external force is acting right above the axis of rotation, do you see any perpendicular distance? No. So R is 0. Yeah, good job. Hosea is correct. So that's what I was looking for. So R for this one, for Fy, R is 0. That's why it is 0 uh, moment in the about the y-axis. Now look at here. So about Fm due to the x. So Fx, now you can see, look, this is Fx. The line of action is this one. And the perpendicular distance is this radius. So this is point 1. The one which you were telling me was for fx, which I did not want to. I asked you about the moment for fy. So that is important. When you are doing your math, you should be aware of that the perpendicular distance is between the line of action of the force to the axis of rotation. And in our case, fy, it is for the moment arm is 0, but for fx it is 0.1. So what is the total, what is the total moment for fx? So I'm gonna write down fy times 0 minus fx times zero point 0.1. And then you will ask me, professor, what is you'll ask me, professor, why is it a negative sign here? So the way I'm doing, say, so I'm sorry, this is counter. I'm saying counterclockwise we consider as positive rotation. Positive moment is counterclockwise. So this, when you pivot this point, if you put finger here, this force will try to move this gear to the right, the clockwise direction. Therefore I wrote down negative sign in front of that. So do you understand the two method? One method is the perpendicular distance for the resultant force, and then the second method is resolve the resultant force into vertical and horizontal component, and then do the summation of the two forces, the moment of the two forces. Do you understand this concept? If you understood, please type in yes in the chat box. Sahil says yes, that's good. Sarah says yes, that's good. Celia, good. Jacob, good. Jeremy, good. Okay, let's do the. I'm happy that you have understood the. Let's do one question. The question number 17 from our, because this question number 17. I'm sorry. Question number 12 from our book. So I'm gonna copy this question. Question number 12. So let me see how many students are there in the 38 students. Now, before I solve this question, I want to give you the opportunity to mark your attendance. Please do me a favor, upload the notebook picture, photo, what I'm explaining here. as a class participation number 5. And do you see that I just opened the Dropbox? I give you some time to mark your attendance by uploading the work. While you are doing the attendance, I can continue the lecture. Is this okay? Because you still have about half an hour to upload your notebook photo for the work which I'm explaining. So let's do this problem. A spur gear. A spur gear has a pitch radius of 2.5 inches. So this is 2.5 inches. During the gear train's operation, a 200-pound force meshing at an angle of 25 degrees relative to the horizontal. This is the horizontal line. The angle is 25 degree. Determine the moment of that force about the center of the shaft. This is the center of the shaft, point O. Using the perpendicular lever arm, using the components method. So let's do one. Would it be 211? Let me see. I want to show you. I want to show you. This is to be changed. Let's change it to 500 pounds. To 500 pounds because you will get the same problem. So I want to change some numbers. So I'm going to change this to 500 pounds now. Let's keep the angle same. So the first method is the perpendicular lever arm. If I go back to my perpendicular lever arm, you see, I drew a line passing through the force vector, and then such that the angle between the perpendicular line between the this angle is 90 degree from point axis of rotation to the tangent of the line. So I'm gonna show you. So I'm gonna extend this line. I'm gonna extend this line. This is lever arm. You see perpendicular lever arm. So this distance is 2.5 because it is radius, pitch radius. Correct. This is angle. This F equals to 500. There is one mistake. The mistake here. This is not exactly 2.5 because you know what? Let me tell you. This is a radius. The line of action is little bit inside. If you take a closer look, it's not exactly on that circumference. This is so. This is it's a right angle triangle. So what is this side? This side is what is that side? So in order to do that, you have to understand some geometry. So this is the like 25 degree. So the way I'm doing it here, 90 minus 25, 90 degree. So that's how you will solve this. Have you understood the angle? How did I write down it? So what is this side equal? Adjacent to this angle, this is D. This is supposed to this is D cosine 25. Do you understand that? The moment arm is not exactly equal to D, but it is equal to, so R equals to D cosine 25. So the moment would be the force times R. And what is the force? Force is 500 pounds. So can I write down like 500 pounds times D? Can you solve this for me? What do you guys get? Please type in the chat box the answer. 'I need my answer in pounds inch. 500 times. I got the same answer. Tristan is correct. Pounds inch. Good job. So this is correct. Thank you. So it is pounds inch. So this is the moment about point O when you are doing the first method, which is the perpendicular to the line of action. Let's do the second method, the one which I explained you earlier. So suppose this is a force acting over here. You have to resolve it into two components. So let me show you another method. So do you get the same answer using this other method? So let me show you. This is my gear and this is my accelerator. The line of action of the force is, I'm going to resolve it in two components. One component is this, one component is this. And this is passing through the axis of rotation. And this angle, look, this angle is given 25 degree. $65. Now, guys, if this is F, what is this side equal to? F sine 25. Agreed. And what is this side equals to? This is equals to F cosine 25. So let's do the moment about point O. So by the way, what is F? Y. If you do the math, what do you get? I'm getting, let's do this, 500 times sine 25. I'm getting 121.3 pound. And this is, so how about this one? 500 times cosine 453. Okay, now we have found the values of these forces. The moment about point O using the Fy. Let's use the Fy first. What is the moment arm for this Fy? Please type in the chat box. I want to know what is R value for this component. 0. Good job. How about if you pivot this point and this vector, this force vector will try to, what is this side equal? This exactly equals to D. So I can write, and this will move clockwise. So I'm going to write down negative sign Fx times D. Now what I'm gonna show you, this is 0. Negative Fx is this much is Fx. Okay, this is my Fx. 453. Can you see? This should be equal to this answer, the one which I show, 1132. Do you get 1132? Let me check in my notes in my calculator. 453.15 times. I got the same answer. So now, have you understood that you can use either the lever arm or the resolution of forces? Either method is acceptable for finding the net moment about the axis of rotation. Have you understood this question number 12 from your homework problems? Please type in yes if you have understood the question number 12. Sahil, yes. Amos, yes. Alexander, yes. Jacob. That's good, guys. I'm glad that you have learned this. This was a little tough, but I'm glad you guys have understood the tough method. So let's come to the question number 17. But before I do that, I want to give you some knowledge I've explained to you the moment of a force is force times the moment arm. The line of action is a line passing through the force, and then you draw the perpendicular. Equilibrium of forces, that the forces, they do not let the body move, the balance out. Equilibrium conditions are three. All the forces along the x-axis, they are equal to zero. All the forces along the y-axis, they are equal to zero. All the moments were. So these are the three conditions: the force balance and the moment balance. Let me show you further explanation. Force balance, because the body remains at rest even after you apply the forces, it is not moving. It means the net force or the net moment is zero. Then comes some understanding about the free body diagram. There is a word free body diagram many times in your classes, coming classes, like dynamics, vibrations. You have to you have to show the professor the force vectors when you isolate a mass. Suppose you are hearing, look over here, this is a free body diagram, like this reaction at this wheel, reaction for this, and the weight acting now, and there is another weight acting in it. So all these force vectors you have to show us. So let's solve one problem. Before I solve one problem, I want to show you. Yeah, you will study the slides at home by yourself. Let me see how many students are present today. 33. 33 students are present. So let me show you what I'm explaining here. A little bit new concept that you might have seen some shaft and axle. You, when you are doing your forward engineering design project, then you will use the bearings. I advise you to use bearing, like you have seen the bearing in the fidget spinners, or when the shaft wants to isolate the motion of the shaft inside. The shaft goes through this inner race, and then the outer it is stationary, this is grounded, okay. Only the inner ring rotates, so the shaft rotates, so that way the whole engine or assembly is not rotating, only the shaft rotates inside the inner race or inner ring. Outer race is attached with the block or the engine housing. Then some, they have very low friction, they are roller bearings and they have very low friction, and some of the technical terminologies are written here, like outer race, outer ring, inner race, inner ring, and separator is this. And sometimes you don't see any bearings. Look, you don't see any bearings. This kind of situation, when you don't see the bearings, this is known as the bushings. We call that bushings. So sometimes these are, have you seen the crankshaft in our engine? So it has like a, this is a big crankshaft, so I'm going to show you. This is, and there is a connecting rod here, and it goes to the piston. So the piston reciprocates inside the engine block. So this is the engine block, everything, and this is the crankshaft, and this is spark plug. Fire happens here, and this shaft, it has a flywheel. It rotates. We generate energy. This, so over here, this kind of situation, this is not a ball bearing. This is known as the, so the journal bearing, the journal bearing, or when there is no roller, when there are no balls or no rollers installed. So let me show you the next thing here. There are some of the names. Okay, let's do the last question before you leave. So let's do question number 17, which is our last question. So a trough of concrete weighs about 800 pounds. Let's make it 600 pounds, okay? 600. Draw the free body diagram of the cable ring, treating the ring as a particle. Determine the tensions AB, AC. So let me show you how are you going to show the free body diagram. So this is the ring, and when you isolate this, so this is how you draw the free body diagram of the ring. So I would say this is tension here, this is tension here, this is tension here. So it is asking you find the tension in the cables AB and AC. So this is my A, this is my point B, this is point C. So you have to find out T1, T2. So let's apply the equilibrium condition. What was the equilibrium condition? Like over here, all the forces, let me grab this, all the forces along the horizontal direction, they are equal to 0. Along the vertical direction, they are equal to 0. And the moment about the axis. So let's do this. All the horizontal forces. So let me show you. Let's do this. This is my horizontal line. This is my vertical. I'm going to resolve these two vectors. So let's do this. All the forces along the x axis. So what is this angle? What is this angle? This angle, if you take closer look, It is 30. These are two equilibrium conditions. Like both are 30 degree. Now, can you tell me what is this T1x equals to and what is T2x equals to? So this is on the left right hand side. So I'm gonna assume this is my positive is to the right. So I can write down T2x positive minus T1x negative. This is how you are going to write down the forces with the negative and positive sign. We call it algebraically. So what is, can I write down T2x and T1x in terms of angle? So T1 cosine 30 equals to T2 cosine 30. Agreed? Please type in yes in your chat box if you agree with your professor. Do you agree with your professor? So Alexander says yes. Okay, good job. Okay, now let's form the science. Apply the second equilibrium condition. I'm gonna use this positive upward. All the forces along the y equals 0. So let's use this free body diagram. F T3 and T1 downward, T2 y downward. So T2 y downward, T1 y downward. Only T1 T3 is upward. So can I write down like this? T3. Let me zoom out a little bit. T3 is positive minus T1y minus T2y. So now what is 600? So can you help your professor? So what is this? This is T1y is T1 sine. So can I write down 600? That is our given. The weight of the concrete is 600 pounds. That's good. So minus T1y. T1 is sine 30 minus T2y, which is T2 sine 30. Now we have two equations, two unknowns. From here, this is T1 equals to T2. This is a very useful information. So we can make one unknown in the second equation. I can replace it by T1 from here. Okay. Now can I write down 600? So can 2T1 sine 30 equals to 600. Can I write down like this? Now you just do the math and let me know what is the answer for T1. Whatever you get T1, you should get the same answer for T2. Please open your notebook and solve, open your calculators, solve for T1 from this equation. Let me know what do you guys get. Alexander says 600. I want to see 2, 3 more students. This is in pounds, right? Cole says 600. Sahil says 600. Okay, that's good. So from equation 1, T1 equals to T2. So this is also equal to 600 pounds. Tristan says, okay, Tristan, let me show you. Look over here. Can I write down T1 from this equation? T1 equals to 600 divided by 2 times sine 30. Can I write down like this? And what is sine 30 equals to? 1 half. Agreed. So 2 times 1 half is 1, so it is 600. Agreed. Do you understand? Please type in yes. If you understood, how did we get T1 equals to 600 pounds? Okay, let me stop the recording now. And recording will be available. So now today